Hey, what's up? What's up? It is Thursday, December 13th, 2024. I got to get out my writing pad. So while I'm doing that, y'all write down the agenda, and then we're going to go to the next one. So make sure you get that in. Pause the screen if you need it. Nope, we still not plugged in. We still not. Now we plugged in. Now we got the plug. Let's go. All right, cool. Off the top, we got entry activity number 22. Pause the screen, get this done. Convert into scientific notation. Again, convert into scientific notation. Don't wait for me to do it. Do it yourself. Try. Give your best effort. Look at your notes from yesterday. Handle the business. Then unpause the screen. Okay? Then unpause. You knew I was gonna do this. Did you get all that done? Did you get all that done on this screen? Did you get this done? If not, pause the screen right now and get it done. Don't wait for me, because every time you do that, that's like me doing the reps for you, and then you wondering why you're not getting better. You gotta get your practice reps in. Okay, cool. So let me see if I can find. Got my pen here, handy dandy. Yep. Okay. So let's just go like this. All right, first of all, the decimal place is here, right? Let's just talk about this. It's a big number, so that means it's got to move to the left. It also means that our exponent should be positive, so let's just see how many we got. We're going to move from right here. 1, 2, 3, 4, 5, 6, 7, 8. There we go, because now we're at 2.99, and that is between, right? So that is between 1 and 10, so we're at 2.99 times 10, and I don't remember what we said. So 1, 2, 3, 4, 5, wait, oh my gosh, I lost it. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8 millimeters per second, and that is approximately the speed of light. Just in case you wanted to know. Okay, let's try this one. This one is very similar. So we're going to go here and be like 1, 2, 3, 4, 5. So we're going to go to 2.39 because that is between 1 and 10. Okay, because the coefficient needs to be 1 and 10. So we'll go 2.39 times 10, right? Times 10 to the 5 miles. So again, big number, positive exponent. This is the approximate distance from the Earth to the moon, okay? 239,000 miles. Okay. Now, this is grams. So let's go here. And in this case, we need to get over to where it's 5.8 because that's where we need to get to. So this is where our decimal is. So we're going to go 1, 2, 3, 4, 5. And since it's a small number, we're going to have a negative, again, a negative decimal point. So 5.8 times, or not negative decimal point, negative exponent. Negative 5 grams. Oh, no, we're right. 5.8 times 10 to the negative 5 grams, right? And this is the mass of a grain of salt. So I actually picked like relative things. So hopefully you were able to get all of these done and you were like, yeah, I got them. And if not, hopefully you see why and what you needed to do. Again, big numbers, you're going to get a positive exponent. Small numbers, you're going to get a negative exponent. That's how I think of it. And again, you're just trying to make sure this coefficient that's out in front, that thing needs to be between 1 and 10. All right, so where does a snowman usually keep his money? Hopefully you're good with this. Yeah, it's a snowbank. Yeah. Okay, let's keep it moving. Now, the journal check is going to be due today. I put that in the system. It is due today. So I'm going to check them while everyone is in class, while everyone's doing the next lab that we're about to do. So just make sure to do that. Make sure you're good with that. And if you are not here, then please just submit your journal check. It is in modules already, so it's already in there for you to submit. Next things next is I just wanted, we just talked about these things, so make sure you are good with that. Make sure you're also good with being able to write a hypothesis. Remember, it's an unproven theory, claim, or statement. Remember that gravity causes objects with mass to attract to one another. All right, cool. And we just talked about these things, about scientific notation. These are all the things you're going to need for the lab. Let's keep it pushing. Let's keep it pushing. Oh, let me turn that off. Boom. Okay, so we talked about these all yesterday, so I just want to make sure that everyone is good with being able to write a hypothesis. So just remember that the first part of the hypothesis is going to be like what is happening. So will the number of tardies change if teachers are standing at their doors greeting students? The prediction is the number of tardies will decrease, right? And so as you put your hypothesis together, if teachers stand at their doors and greet students, then, right, put your prediction here, then the number of tardies will decrease. And that's how you write a hypothesis, okay? All right, cool. Let's move to the next thing, is just this graph and being able to read it. And hopefully you're good. Just take a second with being able to read this thing, okay? So just remember, right, teachers at the door, it looks like that their number is going up. Okay, so as more teachers are at the door, what is happening to the number of tardies? The number of tardies is going down the more teachers there are out at the door on average. And remember, this line is the line of best fit, or it's what we would call average slope. So if you took the slope of those two numbers, took the slope of these two numbers, took the slope of these two numbers, took the slope of these two numbers, these two, and then these 2 points, and then you average them all together, you would get this slope. This is the average slope of all of those, okay? All right, cool. With that being said, turn in your Explore number 1, and then move on, read the directions, and go on to Explore number 2. So you're going to turn in Explore number 1, and then you're going to go on to Explore number 2, which is this one right here on page 85 and 86. And if you look, it asks you a question off top, and the first thing they want you to do is write a hypothesis. So we just talked about that. Write a hypothesis. If this happens, so the question is, what factors affect the gravitational pull on two massive objects? And then so you would be like, the things that affect the gravitational pull of two massive objects is, right, is what? What is the thing that affects two massive objects? What do you think affects the gravitational pull of two massive objects? And that's what you got to write in your hypothesis there before you get started. So do that first. Also put your name. So do that first. And then if you look here, everything is step by step. Do everything one step at a time. Okay. Set everything up. You're going to click your link. That is all in modules. So here, I'll show you guys. Bam. And then let's go here. Oops, not that. Not that. Yes, we definitely can go here. Modules. So you would click here, right? Boom. Explore number 2. Sauce. And then here is that. And then it'll pull this up. And then you just need to follow the instructions. Again, follow the instructions. It tells you everything to do step by step. So make sure to do that, okay? Whoa, whoa, whoa. I don't even know where my slide went. So make sure to just follow the instructions on this page and get everything set up, okay, properly. And then make sure to write everything down, all right? Other than that, by the way, I do also want to show you guys this. Right here where it says decimal notation, what do you see here? Scientific notation. So you can either you do it yourself or have them do it for you. Do with that what you please. Do what you want, okay? Other than that, do your best, and then we will talk about this lab tomorrow. All right, y'all. Peace. Oh, one other thing I forgot. Sorry. Let me make sure we're good. Is you got to do this whole portion right here and then move over to analyze the data. So there is a graph, so you're going to have to do a little bit of graphing. So hopefully you're good at graphing. And then also you're going to need to answer the conclusion question. So make sure you complete this whole lab on both pages. We will talk about this tomorrow. I want you to try to graph yourself. Who's supposed to be on the X, right? Then who's supposed to be on the Y? So remember, the independent variable goes on the X axis and the dependent variable goes on the Y axis. Okay, so yes. All of these things that we've been learning do come back. All right, y'all. Peace.